Okay, so today I'm doing 5.1, which is multiplying and dividing expressions with common bases. I actually have a video of this already that I recorded back in August, and so I'm basically updating it so that way, changing it based off of how I explained it last time, adding in more examples. So if you've seen that video, then this will be very similar, but I might be explaining things differently. There will be definitely more examples. So 5.1 covers several things. We've got review of exponential notation, evaluating expressions with exponents, multiplying and dividing expressions with common bases, simplifying expressions with exponents, and applications of exponents. I'm going to be focusing on the algebra part, not necessarily the applications, because the applications are they're not hard for this section. They're pretty easy. It's usually the simplifying that gets people, so that's what I'm going to focus on. So just a review of what exponential notation means is that you have this value that is it's kind of higher up on your letter. I mean, it's kind of, there's so much to describe, so many vocabulary terms here. So the number or letter underneath is called the base. And then what is kind of smaller and up to the top, that is the exponent. And so that's called a superscript. If you're looking for how to type it on your computer, they use the term superscript. And it just means repeated multiplication. So whatever number is in the exponent tells you how many times that thing is multiplied. So if it's 2, then you have b times b. If it's 5, then you have 5 b's multiplied together. Now, an exponential expression is something that involves exponents, and there's no equal sign. So the key about an expression is that there is no equal sign. Because if there's an equal, then it's an equation. So it's just something without an equal sign that has exponents. And so some examples of this could be x squared, which is a very common exponential expression. You could have things with numbers like 5 cubed. You could have a combination of those, like 5x squared. So as long as there is an exponent somewhere, then it's an exponential expression. And you can even have exponents in a denominator of a fraction, like if you have 1 over x cubed. If there's an exponent, it's an exponential expression. It doesn't matter where the exponent is or if there's other things involved. It's just that that exponent is the key to knowing whether it's 1 or not. And when we simplify these or when we evaluate these, we're following the order of operations, which was covered in Chapter 1. And just a review of the order of operations, we say PEMDAS. So please excuse my dear Aunt Sally, basically parentheses, exponents, then multiplication and division, which can go left to right, and then addition and subtraction, which always goes left to right. And then there are some additional rules we need to learn in addition to the order of operations to deal with these exponents to simplify them. So this section has 2 of them, multiplying and dividing rules. But before we get to those rules, we are going to do some review of just evaluating these. So this green might have been a poor choice now that I'm looking at it on my screen. But evaluate the following expressions. So first we have -1 to the 21st power. So -1 is just -1. If to any exponent is -1 times -1 times -1, repeated multiplication. And the 21 means we have -1 21 times. Now we don't have to actually write this out. So because 1 times 1 is 1, so -1 times -1 is 1. We know we're going to get 1 out. So we don't have to worry about the actual number. The key is our answer going to be positive or negative? So 21 is an odd number. And if you have an odd number, and you have a negative, so negative is inside a plus an odd exponent, that means your answer is going to be odd. I'm not odd, negative. That's going to have a negative answer. So that means our answer here is going to be -1, because we know 1 times 1 times 1, just you're always going to get 1. And then because we have a negative involved, we have to determine, is our answer positive or negative. It's an odd number, so our result is negative, so our answer is -1. And you can verify that by putting it in your calculator. And when you enter it in your calculator, it's really important to have parentheses surrounding the -1 to make sure that you were entering it correctly. Now, the second example here where we're evaluating, we have -1/4 squared. So this one is -1/4 times -1/4. Because that 2 means we're multiplying it, whereas 2 of them multiplied together. Now, if we look at our exponent, we have an even number up in the exponent, and then we have that negative. So in this case, if you put those two together, a negative inside that has an exponent plus an even exponent always gets you a positive answer. So that's just something that will always happen. So if it was a 5 up there, it would be negative. If it's a 6, 6 is even, it's going to give you a positive result. And you can see that we have -1/4 times -1/4. A negative times a negative is a positive. So those two negatives cancel, and then we're multiplying the fractions. When we multiply the fractions, we multiply the tops together and the bottoms together. So 1 times 1 is 1, and 4 times 4 is 16. So our answer here is 1/16. Now, the third one we have -2 to the 5th. This is different from like the first one because the -2 is not in parentheses. This is the same thing as if we had 2 to the 5th and then a negative outside there. So it's very different. You do the 2 to the 5th first and then you deal with the negative. So this would be a negative, and then you have 2 times 2 times 2 times 2 times 2. We've got 5 of them multiplied together. Now in this case, I would use your calculator to do 2 to the 5th. On my calculator, I have a button that looks like that to indicate exponents. And so I would type 2, hit that button, and then hit 5. And when I do that, I should get 32. Yes, 32. So this gives us an answer of -32. In this case, when you enter it in your calculator, you would enter it in your calculator exactly as you see it, and you should get the same answer. If you just literally type in -2, my little exponent button, and then 5, you'll get -32. So are there any questions on this slide where I am reviewing the exponents? Okay. So our first rule that we're learning in 5.1 is the multiplication rule for exponents. Basically, what happens if you're multiplying two things together and they both have exponents? So I've started with a mathematical definition here. Assume that b is a real number and that m and n represent positive integers. So we have positive whole numbers as our exponents, not negatives or anything like that. If they have the same base, the exponents get added together. So b to the m times b to the n equals b to the m plus n. So we're adding exponents when we're multiplying things with exponents. And why this occurs, well, let's look at my example here on the left. If I have 2 squared times 2 to the 3rd. If I expand this out, 2 squared is 2 times 2. And 2 to the third is 2 times 2 times 2. There's 3 of them together. When you count how many 2's I have multiplied, I now have 5 of them multiplied together. So that gives me 2 to the 5th as the final answer. So basically, those exponents 2 and 3, those got added together, and that gets me 2 to the 5th. So another example of this would be, let's say I have 3 squared times 3 to the 4th. You would add the exponents. That is equal to 3 to the 6th, because 2 plus 4 equals 6. It's the same thing if you have letters. So if I had a to the 3rd times a to the 7th, I add the exponents together, 3 plus 7, and that gives me a to the 10. So you add the exponents. The key is that they have to have the same base. So if I had something that was different, like if I had a squared and then b to the 4th times b to the 10th, the a does not get included because it's different base. It's not the same letter in the bottom as the b's. So you only add the exponents for the b's. And so your a squared would stay the same, and then you add the exponents on the b's, which would give you 14. So these are 3 different examples of using this multiplication rule of exponents. So a few more. You would use this exponent rule if it says simplify. So if it says simplify the following, that indicates to you that you need to try to combine these things with exponents as much as possible so that you have fewer things written down, essentially. So the first one, we have w to the 4th and w to the 7th. So those have the same base, w. So you add those exponents together, 4 plus 7. And if you want to write that out, you can write out that step if it helps you when you're taking notes. And then 4 plus 7 is 11. So we get w to the 11th power. Now, middle one here, I have b squared times b. So a very common thing people do is they see, oh, that's 2 plus 0. But we actually, if we have something without an exponent, we assume the exponent is 1 because there's only one of them there. So this is actually b squared times b to the 1st power. So there is an exponent there. It's just not written whenever it's a 1. So when we combine these, we're actually adding 2 plus 1 together, which gives us b to the 3rd power, or b cubed. So if you see something without an exponent, you're always allowed to give it an exponent of 1, and then that will allow you to see that you add those together. Third one here, I've got 6 to the 7th times 6 to the 5th. So we add the exponents, that's 7 plus 5, and then that gives us 6 to the 12th. You don't want to actually put 6 to the 12th on your calculator because it is going to be a gigantic number. And so it's better to just write it as 6 to the 12th because it's less things to write down rather than writing a number that has like 14 different digits or something like that. So you can leave that as 6 to the 12th. We usually, if you did that on your calculator, if it's under 1,000, we will write it out. If it's more than 1,000, then we'll just leave it in the exponent form. It's just a general guideline. That particular number comes up really big, so we're definitely not going to write it out. Are there any questions so far? Okay. Now moving on to the division rule. So this is where you have exponents and there's a fraction involved because a fraction is essentially division. Now, in order to use this rule, the denominator can't be 0, and we can't have 0 as a base. So if there's 0 involved, it messes things up. So just assume 0 is not involved. And again, our exponents are going to be positive numbers and whole numbers. So this is sort of the opposite of the multiplication, where when it's multiplication, you add the exponent. In this case, you subtract them. And you always do the top minus the bottom. So it always has to be top minus bottom, otherwise you could get the wrong answer. So you want to pay attention to that. And so why we have this rule is if we look to the left, I have an example, 2 to the 7th times 2 squared. So if you wrote out 2 to the 7th, that's 7 2's multiplied together. So I make sure I have 7 of them. And then on the denominator, 2 squared is 2 times 2. Well, if you remember back when way back in week 1 when we were doing things with fractions, and you can write fractions as a product of primes, or you can write them out and you can cancel things out that are on the top and the bottom. That's sort of what's happening here. So I can cancel out a 2 on the top and the bottom, and I can cancel another one out on the top and the bottom, and you keep going until there's nothing else to cancel. So I was able to remove 2 from the top and 2 from the bottom because those cancel out. And then I'm left with 5 2's remaining. So that gives me an answer of 2 to the 5th. So basically I removed two 2's from the top, which is when you think of removing something, you're subtracting it. So that's why the subtraction rule is a thing. So some examples here is we have h to the 3rd over h squared. So you're always subtracting the top minus the bottom. So that would be like 3 minus 2. So that comes out h to the 1st power. And that could just be written as regular h. You don't have to write the exponent there. If we have h squared over h squared, when you subtract on the exponents 2 minus 2, you get 0. This is h to the 0. Now, anything to the 0 power is equal to 1. We learned that in the first week when we started talking about exponents. So we actually get an answer of 1 here. And that's because when you have the same thing on the top and the same thing on the bottom, they cancel out and you're left with 1 because you're basically dividing them. And like 2 divided by 2 gets you 1. 5 divided by 5 gets you 1. It's the same thing with letters, with variables and exponents. If it's the same thing on the top and the bottom, they cancel out, you're left with 1. Now, this third one here, if we follow our rule, we get 2 minus 3. You actually get a negative exponent. And that is okay. It is possible to get negative exponents. That is something that actually is covered in, I think it's in 5.2 or 5.3. But we are not going to cover those in this class. Those are going to show up in college algebra. But I did want to just kind of show you that you can get negative exponents, and those actually do have a meaning. And then the last one I have here, we have h squared over h. So that h in the bottom, you can write that with an exponent. So that'd be h squared over h to the 1st. So if it has no exponent, you can put 1 there. And so that would be h to the 2 minus 1, which gives you h to the 1st. So that actually comes out to the same answer as the first one we had. So you're always subtracting top minus bottom. So here's some more examples. And again, these say simplify, so that means you're trying to make it into one thing with an exponent, and you're trying to get rid of the fraction if possible. So you're just subtracting the top minus the bottom. So first one here, I have z to the 5th over z to the 4th. So we would be subtracting top minus the bottom. You're subtracting your exponents, 5 minus 4. So That gives you z to the first power, which we usually just write as z. We usually don't write that exponent there. Second one, we have b to the 12th over b, and so that b in the denominator doesn't have an exponent, so we're going to give it an exponent of 1, and then you can subtract those exponents. So that's 12 minus 1, and that gives you b to the 11. And this works with numbers too. So we have 2 to the 6th over 2 to the 4th. So when you subtract, that's 6 minus 4. It gives you 2 squared. And then that one is simple enough. We will evaluate that and get 4, because that one evaluate means find the answer, basically plug it into your calculator, so to speak. And so the result is less than 1,000, so we will write that out, and we will write that as 4. So are there any questions here? Okay, so the two basic rules, and now we're going to start combining those rules into things that are a little more complicated. So again, all of these say simplify, and that means you're trying to make it one thing with an exponent if possible. So I have b to the 7th times b squared times b. So I'm going to rewrite this so that my times b has an exponent of 1. And when there's 3 of them, it's the same rule. You're adding them all together. So that's going to be 7 plus 2 plus 1. So it doesn't matter how many you have in a row, you always add the exponents because the base is the same. It has the same letter underneath. So 7 plus 2 plus 1, that comes out to 10. So your answer is b to the 10. And you can see that's definitely simpler than the top. The top has 3 things. Here you just have a single b written out. Now the one on the right, we have a combination of multiplication and division here. And so this is where the order of operations kind of comes along. When you have something that has multiplication and division, and it's a fraction, we always simplify the top before we simplify the bottom. So that means we need to do the multiplication on the top, simplify that, and then we'll do the division. So I'm going to write this first. If you're multiplying on the top, you follow the rules where you add the exponents. So that's going to be h to the exponent of 3 plus h over h to the 7. And so then, and I gave myself lots of room to the right because I wasn't sure how much so I was writing the first example I wrote down. But because these are expressions, if you want, you can also go to the right. So if I add the exponents 3 plus 8, that gives me h to 11, and then I have h to the 7. But we're not done, because now all we did was simplify the multiplication. Now we need to do the division. So now we have to do the subtraction part. So if you want, you can keep going to the right. And so we're subtracting top minus bottom. So that's 11 minus 7. And then 11 minus 7 gives you 4. So our final answer is h to the 4th. So we had to do this in multiple steps. And you can go, since it's an expression, you can go to the right as long as the left side is equal to the right side and everything is equivalent. Whenever we have equations, we have to go vertically. I chose to go to the right for this example just because it has multiple steps, and I was afraid I wouldn't have enough vertical space, so I went to the right. But you can do either one, just as long as you're consistent. And just with equations, you have to go vertically. So feel free to ask questions at any time. You can interrupt me if there's things you don't understand or if I'm going too quickly. Yes. Sandra, do you have a question? It showed you typing something, now it's disappeared. Okay, it says you raised your hand again. Oh, I've made this so perfect. I'm glad that this is making sense. That's really important. I'm trying to work it like, small steps. I don't want to make it too confusing. It's really not as bad as it looks, but I do have more complicated examples, so we'll see how those go. Because once you start throwing in numbers and parentheses like I have here, it does look kind of scary. And it's all about organizing things so that you keep things together that go together. With the zero, yeah, if there's anything that comes out to zero, you don't have to write those out. Unless you're like multiplying by zero or something like that. So let's see, I don't have anything like this. Yeah, none of these basically came out to zero. So let's look at my example 4 here, where I've got ones that start involving numbers and they're involving different combinations of letters. So the first one on the left, I have 2x cubed times 3x to the 4th. So when we're multiplying, when we have things that are multiplied together, we have the commutative property, which says that you can rearrange the order that things are multiplied. And so that's what we're going to do. So I've got the 2 and the 3. Those, I can multiply 2 times 3 together. Those sort of go together. So I can rearrange this so that I have 2 times 3 together. And then the x's, those have the same base. So I can rearrange this so that things with the x go together. So that's using the commutative property. As long as things are all multiplied together, you can move things around to whichever makes it convenient for you. So when you do that, you can say, oh, okay, I can do 2 times 3, so that gets me 6. And then with your exponents, we have the same base x, so we add the exponents because they're multiplied together, so that's going to be 3 plus 4. And then when you add that, that gives you 7. So our result here ends up being 6x to the 7th. Now 6 is a number, x to the 7th has a variable, so we can't really combine those anymore. So that's as simple as that particular example goes. Now the one on the right, again, I left myself more room here because this is going to be more space. And so we have 5a squared b times 8a to the 3rd, b to the 4th. So again, I'm going to group things together because everything is multiplied. So I can put the 5 and the 8 together. Those are both numbers. So that can be 5 times 8. And then I'm going to group things by their variable. So we have a squared and then a cubed. So I can group those together because those both have the same base. And then with the b's, I can group the b and the b to the 4th together. And I'm also going to put an exponent of 1 on the b because it doesn't have an exponent. So all I've done is just rearrange things here and grouped things that are similar together. The numbers together, the things with a together, the things with b together. And now I'm going to start multiplying. So 5 times 8, I can multiply it together. That gets me 40. Now with the a's, I can add those exponents together. So that's going to be 2 plus 3. And then I'm going to look at the b's and I add those exponents together, which would be 1 plus 4. So I have to work, I can't just add all the a's and b's together because they have different letters. So I have to do the a's separately from the b's. So then that gives me 40. And when I add my exponents, I get a to the 5th and b to the 5th. And I can't go any further because a and b are different letters, so I can't multiply those together. Those have to stay separate. You can only combine them if they have the same base, the same thing under the exponent. So while it looks really complicated in the first step, it's really not so bad. And a lot of times I just do this in my head, do the multiplication and adding in my head, but I'm making sure to write every step here so that you can see exactly what's going on and why we're allowed to do what we're doing. I'm glad this is so much easier. It's really not bad at all. And the whole reason we're going through this section is because 5.4, you're multiplying, and so you're going to have to multiply these things together, and so you need this for 5.4. And when we do factoring next week, we start dividing these things. So the skill, knowing how to multiply these things with exponents and divide these things with exponents, those are helpful for what we're going to be doing later. And it's really not, a lot of people get scared of math. It's really not so bad once you know the rules and you go step by step. So here, now I've got some more complicated ones with the division, and I know with fractions people really freak out, but it's really not so bad. And these are my last two examples here. So I'm going to start with the one on the left. I have 14c to the 4th d to the 5th over 7c to the 3rd d. So just like with the multiplication, I'm going to put the things together that are similar to, that have the same letter or like our numbers, like the 14 over 7. So the thing about when you have fractions, you can split them up. Just like, let's say I have 3 halves times 5 to the 4th. When we multiply fractions, we're multiplying the top together, and we're multiplying the bottom together. So if I have something that looks like what's on the right, I can kind of split these back up into two separate parts. So I can move from something on the right to go to something on the left instead of going from the left to the right. And so that's the idea that we're going to be doing here, is we're going to be splitting things up so that instead of like the 3 different fractions, or the 1 fraction, we're going to actually make it 3 different fractions. So I'm going to be splitting this up. So I'm going to split the 14 over 7 together because those are both numbers. Then I'm going to group the c's together as a separate fraction. That's c to the 4th over c to the 3rd. And then I'm going to group the things with d together as a separate fraction. D to the 5th over d. And then that d does not have an exponent, so I'm going to give it an exponent of 1. So I'm splitting my fraction up into 3 separate fractions multiplied together. And temporarily it looks more complicated, but it's really not, it's going to make things easier for us. So now I want to simplify. So the 14 over 7, I can divide that. 14 divided by 7 is 2, so that gives me 2. Now I have my c to the 4th over c to the 3rd, so I'm going to subtract my exponents because I have division. So it's top minus bottom, so that's going to be 4 minus 3. And then on the d, again, I'm going to subtract. It's always the top minus the bottom, so that's 5 minus 1. So this gives me 2. 4 minus 3 is 1, and then 5 minus 1 is 4. And I can leave off the 1 on my exponent and write it as 2c d to the 4th. So I took something that was a fraction, and it was a single fraction. I separated each part out based off of the things that are similar, and then simplified each thing separately. And then that's how you get your final answer there. So I'm going to do the same thing on the one on the right, where we have 25 h to the 3rd j k to the 5th over 10 h squared k. So I'm going to separate it out. I'm going to have the group the 25 over 10 together. Then I'm going to group the h's together. So h over 3 over h squared. I'm going to group the j together, and that j is alone on the top. It doesn't have anything on the bottom, so we're going to just write a 1 there. And then I have k to the 5th over k. And that k in the bottom does not have an exponent, so I'm going to have a 1. So notice that something's missing, I put a 1 there. So like there's no j on the bottom, so I wrote a 1. The k doesn't have an exponent, so I wrote a 1. So here we've got 4 things, and now I'm going to simplify. So 25 over 10, if you divide that, you get a decimal. So we're not going to write it as a decimal, we're going to write it as a fraction, and we're going to reduce that fraction. So I can divide 5 out of the 25 and the 10. So 25 divided by 5 gives me 5. 10 divided by 5 gives me 2. So that reduces to 5 over 2. Now I'm going to work with the h. I'm going to subtract my exponents. 3 minus 2. The j, if it's just written over 1, I can just write it by itself, because that's basically j divided by 1. Anything by 1 is itself. And then k, I'm going to subtract the exponents. So you want to be very careful here, because we divide numbers and we subtract exponents. You don't want to get those confused, because once people have both numbers and exponents, they usually end up trying to divide, or they're usually trying to subtract the numbers, like 25 minus 10. That's incorrect. You're dividing those and you're subtracting the exponents. So you want to make sure that you're doing the correct thing. You're not getting confused between those two operations. So then I have 5 over 2. And on my h, 3 minus 2 is 1. I have my j, and then the k, 5 minus 1 is 4. So I have 5 over 2 times h times j times k to the 4th. So I can write this h, k, h, j, k to the 4th. Now sometimes people like to keep this as a fraction because I have 5 halves there. And if you do that, everything that doesn't have a fraction goes on the top, and then the denominator goes on the bottom. So you can also write it like on the right. That's 5hjk to the 4th over 2. Those are the same thing, they're just written differently. And there's no requirement to write one or the other. I would say write it the way that makes sense to you, and that is easier for you to follow. So are there any questions? Oh, perfect. I'm so glad that you got it. It's all about just going slowly and just like repeating the steps to yourself. You know, I think that's the best thing. And even just like when you're writing these down, write down, subtract the exponents, divide the numbers. You know, just writing that down every time you work through one of these problems would probably be very helpful. You can even color code, like maybe use a highlighter for everything you divide and then a different color for everything you subtract. Whatever, you know, works for you. But you're definitely going to need this for 5.4. So 5.4 is all the multiplication stuff. So you'll get really good at this when you start doing 5.4, multiplying things out. So those were all the examples I have. So if you have other questions on anything, let me know. Let me stop sharing so you can see my face too. So anything else that you have questions on? Well, I don't see any. Oh, you're typing again. Yes, only when you divide you subtract. Yeah, it's kind of weird because it's like your division, you're not actually dividing the numbers, you're subtracting. It's like one step below the order of operations. And then only when you multiply do you add. Yeah, so, and it's all with the exponents. Keeping it straight is the hardest part. That's why I recommend writing that down maybe each time. Multiply or like add exponents, subtract exponents. So I'm glad that you got this. It's a really important thing, especially if you have to go into further in algebra because we work with exponents a lot. So understanding how exponents work is really important. So yeah, so that's all I've got. I'm planning on having an evening session for week 5. So I need to figure out when that is, but make sure you've done that survey if you haven't yet, or if your schedule has changed, update the survey that I have with like what times you're available, so that way I can make sure I try to get it when most people are available. But thank you so much for joining and asking questions, and I hope you have a really great Sunday afternoon, okay? Bye.